This is Pre-Calculus B, Unit 1, Lesson 4. We're still working on an introduction to trigonometry, but we are learning something called the unit circle. You may recall having studied this a bit in your Algebra 2 class. So we're still talking review, hopefully, but we're going to explore it some more, remind you of some things, and maybe teach some new things as we go. The unit circle is a tool we use to evaluate the trig functions, sine, cosine, tangent, including the reciprocal functions, secant, cosecant, cotangent. Okay, and the essential idea is that we graph angles on a circle of radius 1. So the radius of this circle is 1 unit. So any line segment drawn from the center to a point on the circle is 1 unit in length. Okay, the first thing we need to do is identify some of the common angles here. So let's do that. And that requires memorizing a couple of important triangles. Okay, let's start with the 45, 45, 90. So if I draw a triangle that has a right angle, but the base and the height are the same, this is, if you may consider it such, half of a square, or a grilled cheese sandwich, which we always cut down the middle, right, diagonally. A 45, 45 right triangle has sides, if the hypotenuse is 1, has sides 1 over root 2, or, more correctly, root 2 over 2, to rationalize the denominator. Okay, 45, 45, 90. Okay, that's the sides that you need to memorize, and they do need to be memorized. So if you haven't done so, take some time. Okay, the other triangle is half of a right triangle, or a half of an equilateral triangle. Okay, so half of an equilateral triangle, and it's a, if you figure out the angles of an equilateral triangle are always 60 degrees. If you split 60 in half, you get 30. So this is a 30, 60, 90 triangle. 30, 60, 90 triangle. So the big angle being 60, the small angle being 30, and the right angle 90. If the hypotenuse is 1, then the sides are 1/2. There's always this 1 to 2 relationship between the short leg and the hypotenuse of the 30, 60, 90, and root 3 over 2. Okay, so again, these two triangles really should be memorized. So take some time to write them down, draw them, sketch them, index cards, maybe with some blanks, and quiz yourself repeatedly, maybe daily for a while until you've got it in your long-term memory. Okay. The second piece of evaluating trig functions on the unit circle is to be able to mark out the common angles. Okay. I'm going to mark out some of the common angles using degrees first. I'm not sure the lesson had you do that, but it'll give us a comparison between degrees and radians. So 0 degrees, of course, starts with the positive x-axis. We start there, and angles in the unit circle and in trigonometry are measured counterclockwise. So as we proceed counterclockwise, we go all the way around is 360. So 0 and 360 are coterminal. That's a word meaning they end up with the same terminal ray, 0 degrees and 360 degrees. Okay, half of 360, if we go halfway around the circle, is 180. Half of 180 is 90. 180 and 90 again is 270. So those are some of the common angles here. If we go half of 90, that's 45. If we go 90 and 45, that's 135. If we go 180 and 45, that's 225. 270 and 45, or 360 minus 45, is 215 degrees. I'm sorry, 315 degrees. Okay. And that's splitting in half and splitting in half and splitting in half again. What if we take the 90 degrees and split it into thirds? So I'm going to change colors here. Let's go orange. So split it into thirds. So it's like here. A third of 90 is 30 degrees. 2/3 of 90 is 60 degrees. Okay. 90 plus 30 degrees is 120 degrees. 120 plus 30 is 150. 150 and 30 is 180. 180 and 30 is 210. 210 and 30 is 240. 240 and 30 is 270. 270 and 30. Actually, I got the 315 in the wrong place here. Let me fix that. As best I can. Okay, 315 is right here. 315 degrees, okay. And so we need to go right about here. Yeah. So that's 270 and 30 is 300. 330. Okay, and those are your common reference angles for the unit circle in degrees. Now let's go to radians. 0 radians corresponds with 2 pi radians. 2 pi is all the way around. Half of 2 pi is 1 pi. So pi radians. Half of pi is pi over 2. Pi plus pi over 2 is pi over 2 plus 2 pi over 2, or 3 pi over 2. Okay. All right, that gives us all our half pi's, or 90-degree correspondings. Half of 90, half of pi over 2 is pi over 4. Remember, to half a fraction, you double the denominator. Pi over 2 plus pi over 4, or thinking just counting pi over 4 is 1 pi over 4, 2 pi over 4, 3 pi over 4. 4 pi over 4 is pi. 5 pi over 4. 6 pi over 4 is 3 pi over 2. 7 pi over 4. Okay. All right, now let's go to yellow. Let's do the 30s. The pi over 2 divided by 3. Think 2 times 3, that's pi over 6. So pi over 6 corresponds to 30 degrees. 1 pi over 6, 2 pi over 6 is pi over 3. Reduce the fraction. 3 pi over 6, 4 pi over 6, reduce is 2 pi over 3. 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. Okay. 11 pi over 6. And then 2 pi is 12 pi over 6. There we go. There's our common reference angles, our common angles in radians. And it's good to be able to create this chart. So practice drawing and marking all these angles on your own. I think the idea of including degrees in the chart is really good because it helps you to give a link the radian measure to the degree measure, because we're already familiar with degree, and linking it to previous knowledge helps. Okay, so that's task 1. Be really familiar with these reference circles or reference triangles and be able to mark all the degrees. And now let's use it to evaluate a couple trig functions. Okay, let's go here and add a new layer. And I haven't used red, so I'll use red here. Actually, I think fuchsia will stand out better. Okay. All right, so let's mark an angle here and say I want to find the trig functions associated with 30 degrees. Okay. So I think of, or in this case, I draw the unit circle at 30 degrees. I draw a radius at 30 degrees. Now remember the radius is 1. Okay? And remember this is also pi over 6. So we're going to think in radians. So pi over 6. So the angle is pi over 6. The hypotenuse is 1. This is a 30, 60, 90 triangle. Or pi over 6, pi over 3, and pi over 2 if you want to do them in radians. Okay? 30, 60, 90 triangle. So this side is 1/2 and this side is root 3 over 2. Okay? And this is our reference angle. So think sine, cosine, and tangent, SOHCAHTOA. Sine of pi over 6 equals opposite over hypotenuse, 1/2. Cosine pi over 6 equals adjacent over hypotenuse, root 3 over 2. And notice, by the way, because the hypotenuse is 1, really it turns out that the height of your triangle is sine x. And the width of your triangle is cosine x. And that's good to remember. The width of your triangle is cosine x. The height of your triangle is sine x. Okay, tangent pi over 6 is 1/2 over root 3 over 2. The 2's cancel. This is 1 over root 3. Multiply top and bottom by root 3, and you get root 3 over 3 for tangent. Okay, and I won't take the time to do the reciprocal functions, but sine, the reciprocal of sine is cosecant. And, well, actually I should probably go ahead and do that. The reciprocal of sine is cosecant. And here's how I remember which one goes with which are the cofunctions, which go with if your original function don't got a co, your reciprocal function does got a co, and vice versa. So cosecant pi over 6 is 1 over sine, so it's 2. And secant pi over 6 is the reciprocal of cosine, which is it was root 3 over 2, so it's 2 over root 3, but we got to rationalize the denominator. So 2 root 3 over 3. Okay, and cotangent pi over 6. Think the reciprocal of 1 over root 3 is root 3. Okay, all right, so that's how to find the trig functions here. There is much talk about coterminal angles and stuff, so let's do one of those. Okay. So let's get a new layer here and hide this. Okay. So let's say I've got this angle right down here. Actually, yeah, let's do this. So I've got 225 degrees, or 5 pi over 4. Okay, 5 pi over 4 theta. Okay, what are the coterminal angles to 5 pi over 4? Well, first of all, I can go all the way around the circle again. I can add 2 pi. So 5 pi over 4 plus 2 pi, which is 5 pi over 4, 5 pi over 4, plus 8 pi over 4. Or that is 13 pi over 4, right? So that's coterminal. You can go around again. You can do that for any multiple of 2 pi going around. You can also go around in the negative direction. So think going from 0, counting this direction. This is negative 1 pi over 4, 2 pi over 4, 3 pi over 4. So it's coterminal with negative 3 pi over 4. Which, by the way, is the same as saying you can subtract 2 pi. So 5 pi over 4, take away 2 pi, ends up being 3 pi over 4. Okay, because 8 pi over 4 minus 5 pi over 4 is 3 pi over 4, and 8 pi being bigger, the answer would be negative. Okay, so that idea of coterminal. I also want to deal with one other thing here while I've got this here, in that paying attention to the signs of your trig functions is really important. So remember, up is positive, down is negative, left is negative, right is positive. So let's say I've got, the tangent, let's say I've got the tangent of, and I'll use one of the coterminal angles, negative 5 pi over 4. Okay? The tangent would be the sine over the cosine, right? So this is a 45-45 right triangle. So the sides are root 2 over 2, root 2 over 2. However, this is left root 2 over 2, and this is down root 2 over 2. So both are negative. So tangent being opposite over adjacent, or as you may have figured out already, sine over cosine. Negative root 2 over 2 divided by negative root 2 over 2 is positive 1. Okay, so just be aware of left is negative, down is negative, right is positive, up is positive. And I've spent plenty of time on this video. Let me know if you need help.